In the second part of Lab 2, we're going to learn how to download our own spatial data and then do some basic operations to manipulate our data. We're going to learn how to join shapefiles together by merging them and by appending them. These are two really useful steps. The really cool thing, though, is from the Census Bureau interface, we're going to learn how to download our own data. Now, once you get the hang of this, you'll realize you can download shapefiles from all over the place, from the Census Bureau, from state agencies, from county agencies, City of Baltimore, from many other entities, organizations, people. You can also create your own data. So once you learn these tools in GIS, you'll realize you're really only limited by the spatial data that you can either acquire, which is kind of easy to do, or create. Now, in the case of census data, we're going to take a look at some specific geographies. I'm going to take a look at census tracts. This is a unit that we commonly work with in GIS because they're small. They give us sort of a granular look at conditions on the ground, but they're also large enough to be manageable. When you attempt to download census tracts, what will happen is it'll ask you first, do you want 2000 census tracts or 2010 census tracts? You'll notice no 2020. The 2020 census nominally is being completed, and apparently we're going to get the new geographies soon, but they're not available quite yet, even though it's 2021, August. So soon, we hope, we'll start seeing the updated geographies. For now, though, we tell it we want the most recent version, 2010 census tracts. We can download these for an entire state, or we can identify a county. So what we've seen in our lab is we downloaded Baltimore County, and then here I'm going to download this to my downloads folder, and then I'm going to do Baltimore City, same drill, to the downloads folder, and just for fun, Howard County, like we're doing in the lab. Now the idea here is we've got three contiguous county-wide data sets. We're going to learn ultimately how to bring them together, but first we're going to analyze the properties just a little bit. So I've got all three of these saved to my downloads folder. There they are. And within each of these, what you'll see is a bunch of files. Now collectively we call these a shapefile often. That's the common name for it. Sometimes you'll hear it referred to as a feature class. A feature class is any geographic feature represented spatially or digitally that we can bring into a GIS and layer with other things. Shapefiles are a subtype of feature classes, so are raster data, as we'll see. But here the thing that we call a shapefile is really 5 different shapefile or different files. Collectively, they form a shapefile, and when we look at this object in our GIS, we'll see it's just read as one single thing. The components of this that are absolutely essential are the DBF, the SHP, and the SHX. You have to have all three of these in order for a shapefile to show up in ARC. It won't be read otherwise. PRJ is the projection information, the stuff we were talking about a little bit earlier in the first part of Lab 2. And then we also have this XML file, which is metadata, information about the shapefile, which almost always is woefully lacking. You can always make better metadata and do yourself a favor. Now in Pro, as I've recommended before, you'll notice I have the catalog pane open, and I've mapped my downloads folder. Here you can see those 3 shapefiles that we've loaded, and if I take a look at catalog view, which I encourage you to do every time you're looking at a shapefile for the first time, if I open up that folder here, I'll see these 3 geographies. So I'm looking at Baltimore County, Baltimore, Howard County, and then Baltimore City. So 3 different shapefiles, each of them showing 1 different spatial unit's census tract. So all the census tracts in Baltimore City is what we're looking at right now. Now we can look at the data table for those as well, because remember, shapefiles are made up of both spatial components, that's the .shp part of the shapefile structure, and attributes, which is the .dbf portion of the shapefile structure. So here we're looking at the various attributes or information we have aggregated by, in this case, census tract, which is mostly just reference information. but we do have the latitude and longitude of what's called the centroid of each tract, and we also have the area in square meters of each tract. That just kind of shows up with the shapefile. It can be very helpful when we want to do things like calculate population density. So having looked at the properties, let's look at one more thing. Or having looked at the geography in the table, let's take a look at the properties so that we can see the spatial reference of these files. And you'll see that all three of these files are in the North American Datum of 1983. That is basically a model of the shape and size of the Earth that we're using. It's a mathematical model. It's not exactly the shape and size of the Earth because the Earth is not a perfect ellipsoid. But it's the ellipsoid that we use to reference locations that we then relate to the surface of the Earth. You'll notice that this measures things in degrees, not inches, not miles, not kilometers, so it's measuring things in angular units rather than linear distances. So if we wanted to measure things in miles or square kilometers, we'd probably want to project this into a projected coordinate system rather than working with this, which is a geographic coordinate system. So having looked at this a bit, let's insert a map and add these three files to it so we can play around with the three files and learn the things that we're doing with them in this lab, which is learning how to merge shapefiles and learning how to append shapefiles. Now, one thing that's worth noting is that in ARC, everything happens in the toolbox. So when you go under analysis and say toolbox, you'll see that there's this whole set of operations that we're going to learn a thing or two about. We won't learn all of them by a fair sight, but we're going to learn a lot about some of these tools. And among them are tools that allow us to generalize, which means to do away with distinctions among things and make them general. And another thing we're going to learn how to do is separate things apart. Now, these happen in different places, of course. And so what we're going to do is go to data management tools, and within that there's a tool here called General, or a toolbox called General, and we're looking for the Merge tool within that. The Merge tool allows us to take two shapefiles, so let's say Baltimore County and Baltimore City, and put them together. This creates a new shapefile. Ultimately here I'm putting these in my downloads folder. I'm going to delete these when I'm done, but when you do this you probably want to create a folder called something like Lab 2B where you can save all your stuff. In fact, in the lab there are much more elaborate instructions for structuring your data, which is a really good practice so that when you download things you can find them again. If you shove everything in one folder, it can be very difficult to find things, as you'll see. So when I run this operation, then, it takes those two shapefiles, the original two shapefiles, and it is putting out a new shapefile, which has combined the original two. So once I symbolize the result and make it look a little bit different, when I turn off the merged file, I can look at the original two files that make it up, Baltimore City and County. And what has happened is we've taken the shapes of one, the shapes of the other, and we've turned those together because they don't overlap. They are mutually exclusive. When we combine them, it turns it into a single object. All of the attributes are combined. Now, it just so happens that the attributes are identical. It makes it rather simple when we merge things like tracks with tracks. Now, another way we can go about this is keep in mind when we do the merge operation, we're taking two shapefiles and turning them into a new shapefile. We can also take a shapefile and add things to that shapefile. So the output is the original shapefile. We're just appending new shapes to it. And to do that, we're going to use a tool called Append. And the Append tool is also located within that data management tool box within the general toolbox underneath it, and the Append tool asks you two things. It says, what is the input data set? In this case, that would be Howard County. And the target data set is the merge data set that we are putting data into. Now, the output will be that merged data set. It's just going to have an additional set of census tracts in it, the ones from Howard County. I just want to point out something about these numbers here. TL 2010 means that we're looking at Tiger Line data from the Census Bureau, that's the TL, from 2010, from the 2010 wave of the census. Every 10 years they update their boundaries as populations shift. This then has this 5-digit number, 24027. 24 means Maryland. 027 means Howard County. And so 24027 is Howard County within the state of Maryland. These are what we call FIPS codes. You'll get more and more familiar with those, but you'll see that lots of data as we download them from the Census Bureau have these codes. So when we click Run, we're going to take Howard County and append it to this merge file that we've already created. We won't be creating a new file, we're just adding information to that file. And there's our new version of the merged file. Now, one thing to notice is if we open up the attributes of any of these files, we can see how many objects are in it. So, for example, Baltimore City has 200 census tracts, or did in 2010. Baltimore County in 2010 had 214, so that's 414 total. And Howard County, and I'm getting this from the very bottom here, had 55, so that's 269, if my math is right. So we should see 469 objects in the final result. So what we've learned so far is just how to grab some spatial data, how to open it up in ARC, how to do some basic manipulations, in this case merging and appending files, to see how the basic properties of these shape files work. We're going to go a lot farther than this as we proceed. The next thing we're going to learn how to do is how to get more attributes, how to get more information about these shapes into the attribute tables of our shape files. That'll be for Lab 2C.